Hi, in this session of STR8CHEM, we're going to learn how to find the density of ideal gas by using PV equals to nRT. Okay, so what we're trying to do first, we need to know how to change this into a formula that we can use in order for us to find the density of the ideal gas. Okay. So what we need to know now is how to get this formula from PV equals to nRT. We need to know how to derive this formula from PV equals to nRT, and that is quite popular to be asked in exams. Okay, so this is your density, and as you can see, you still have the if you look over here, you still have the pressure, okay, and that will still be in ATM or atmospheric pressure. And then you still have your temperature, that will still be in Kelvin. This is the constant 0.0821, and that big M over here is your molar mass of your ideal gas. Okay, so how do we get from PV equals to nRT to this? Okay, so we're going to look at that one, and after we have done the conversion, after we have done the derivation, we're going to look at two examples. PV equals to nRT, we need to convert into this. Okay, that is the symbol for density. And how do you write that? Okay, you're going to write it like this. So that is the symbol for density, not like the usual P, not like that. That is the usual P. So I repeat, I do that again. So the symbol for density, you can write it like this. Okay. Now, so how do we do the conversion from PV equals to nRT to density equals to PM over RT? The first thing we need to look at over here is this. Okay, I'm gonna take your attention to that N over there. Okay, so that N over here can be rewritten as small m mass over big M molar mass, and you can get something like this. Okay, so this N, number of mole, can be rewritten as this. So you have your mass, small m, and then you have your molar mass, capital M, right over here. Why? Because if you still remember, molar mass, so we're just going to put that as capital M for now, is defined as mass in grams, or the symbol is small m, over the number of mole, and the letter we're going to use is N, small n. So that is the formula for molar mass. So when you are going to rearrange that, so when you rearrange that one, you should be getting something like this. So if I'm gonna take this N over that side, okay, so it's a very simple mathematics. So if I times N over here, you're gonna times N on the other side. Okay, if I times N on your if I times N here, I'm gonna times N over here as well. So you're gonna get M times with small n, that one you can cancel out, and you're gonna have your mass on that side. Okay, So if I am going to divide big M over here, and also, yes, I'm going to divide big M on that side, you're going to cancel that out, leaving you with mole over mass over, so you're going to have number of mole equals to mass over molar mass. So this is the one that we have gotten right over here. Okay, so that is the first thing you need to know. So PV, just now you have PV equals to mass over molar mass times with RT. If I am going to switch the side, okay, if I am going to move RT over that side, so divide RT, and over here I'm also going to divide RT. So you can cancel RT on the right hand side, leaving you with PV equals to RT here. So we have PV over RT, and you get mass over molar mass. Okay, small m is for mass, and capital M over here is for molar mass. Now, so what we need to do next is we're gonna get that m on that side. Okay, we're gonna get that m on that side, and then this volume on this side. Why we need to do that? Okay, why do we need to do that? Because if you still remember the one that you have learned before, the formula for density, okay, the formula for density is mass over volume. So if we can get this volume to be down here, you're going to get mass over volume, then you should be able to get your density. Okay, so how do we do that? First, we're gonna take that m to the other side by multiplying m on both sides, so you can cancel that out, and what you get here is something like this: PV, and then you have m over RT, leaving you with mass on the right hand side, okay, on the right hand side of the equation. And what we need to do next, we're going to take this volume to that side. So I'm just going to divide by volume, divide by volume. We can cancel that out, and you should be getting something like this: P, pressure, times molar mass over RT equals to mass over V. Okay, so when you look at this, it is the same as what we have over there. So this is the usual density formula that you have seen before in the past. So if you're going to compare this and that, therefore it's safe for us to write that density. Now the density for this is pressure times molar mass over RT. So that's how you do the conversion. Okay, remember, this derivation is very important because they might gonna ask you in exams, and they might gonna ask you to show how do you change PV equals to nRT to get the formula for density. Okay, to get the formula for density equals to pressure times molar mass over RT. Okay, so that is for the conversion. And now let's have a look at two examples. Okay, two examples for density of ideal gas. This is a very typical, very simple questions on ideal gas when they want you to work out the density. Okay, so as usual, what we need to do, we have to extract all the information. The first thing you need to write down over here is you need to think about what does the question want. So the question wants you to find the density. Okay, so the density. So if you want to find the density, you can use the formula pressure times molar mass over RT. Okay, so I repeat. So what are all of this? So that is your pressure. It needs to be in ATM, remember? And that is your molar mass. This is the temperature. And that should be in Kelvin. And R is the constant with the value of 0.0821 liter atmospheric pressure per mole per Kelvin. Okay, so that is what the question wants. Now, what does the question gives to you? So the question gives a few information. Okay, so the question gives you a few information. So we need to have some pressure. So do we have some pressure given to you? So yes, we have pressure right over here. Go. Okay, so that is your pressure. So that is 932 in millimeter mercury. So when you look at the units of your pressure, of the pressure that is given to you, it is not in atmospheric pressure. So what you need to do before you want to plug in the value into this formula, you need to convert that first into ATM. And then what else given to you? We have temperature. Okay, the temperature is right over here. So the temperature is about 65 degrees Celsius, and that one is also not in the units that we can use to plug in the value into your PM over RT. So we need to do a bit of a conversion. And molar mass, we need to know what is molar mass. Molar mass is not given, but what is given to you is this. So we can get the information for molar mass from there. Okay, so molar mass, what is given to you is SO2. So when you look at your periodic table, when you try to take the information about the molar mass of sulfur and the molar mass of oxygen, when you calculate that molar mass, you should be getting the molar mass of this one about, it's about, okay, so that one should be about 64.07 gram per mole. Okay, so when you do a double check, we have your pressure, yes. We have your temperature, yes. We have your molar mass, yes. And of course, that one is always going to be 0.0821 liter ATM per mole per Kelvin. So before we're going to proceed, what we need to do now, we need to convert this one first, okay? You need to remember to do some conversion. Okay, so the first thing that we can do here is for the pressure. So we're going to convert millimeter mercury to ATM. So how do you do that? So given here, as you can see, this is the relationship that will be provided to you in examination, so you don't have to worry about memorizing the whole thing over here. All you need to do now is to know how to use them, okay? The question gives you, what does the question gives you? So the question gives the pressure is about 932 millimeter mercury. So how do you convert that? So we're going to look over here. From this relationship, this is the relationship that will be constant. 1 ATM is equivalent to 760 millimeter mercury. So 760 millimeter mercury is equivalent to 1 ATM. But the question gives you 932. So in 932 millimeter mercury, what is the value for atmospheric pressure? So that is the thing that we need to think about. We need to know what is this, okay? So how do you do that? You're going to do cross multiplication. So 1 ATM, you multiply with this, okay? You go that direction. You're going to multiply. So you have 1 ATM times 932 millimeter mercury. And then after you have multiplied 1 ATM with 932, when you go up, that one will divide. So you're going to divide with 760 millimeter mercury. So this is proportionality cross multiplication. So when you computate that using your calculator, you should be able to get a value around 1.2263 atmospheric pressure. Okay, so we're going to use that value later on in the determination of the density of ideal gas, which is SO2 in this case. And then next, what we need to do is we need to convert the temperature as well. Okay. Now you're going to convert degrees Celsius into Kelvin, which is very easy. So the question gives 65 degrees Celsius. Okay, so how do we do that? 65 degrees Celsius, you're going to plus with 273.15. So this number will be always the same if you want to convert degrees Celsius to Kelvin. And you should be getting something like 338.15 Kelvin. Now we have converted both pressure and temperature into the suitable units for you to plug in the value into the equation. We can proceed with solving. So now we can find out the density. So the density of SO2, what we can get is 1.2263 ATM times with 64.07 gram per mole over 0.0821 liter HCM per mole per Kelvin, and you have 338.15 Kelvin. Okay, so if you care about your units, you would be able to identify what is the unit for the density. Okay, so HCM and HCM will be cancelled out. Mole over here and mole over there will be cancelled out. Kelvin per Kelvin and Kelvin will be cancelled out. So you are left with liter and gram. Okay, so your final answer, your density, you're gonna get something around 2.83, and the unit is very important. Without the unit, you won't be able to get your 1 mark for your final answer, so that is quite crucial. Gram per liter. Okay, so that is your final answer. So that is the density of SO2. Now, let's have a look at another example. So over here, the question wants you to find the density as well. Okay, so you need to find the density of the ideal gas. So the question wants, so it's good for you to always scrutinize the question. Try to find out important information. Try to find out what does the question want, so that you know what you need to do, what equation you need to use, and so on. So in this case, the question wants you to use density because they want you to find density. So density. So the formula of density, very easy to be remembered, PM over RT. Okay, now, do we have enough information? So we have to look at what does the question give. So the question give, we have molar mass or molecular mass. So M is given, which is 50 gram per mole. And then you have over here, so that is your pressure and that is your temperature. We have pressure equals to 2 atm and temperature equals to 27 degrees Celsius. It seems like we have enough information, and if you look at your pressure, okay, it's already in atmospheric pressure, so you don't have to convert that. The only thing that you need to convert is this. Okay, so we're going to do that now. So we have 27 degrees Celsius plus 273.15, and you would be getting it's around 300.15 Kelvin. Okay, so we can directly plug in all the values into your pressure, molecular mass, R, and temperature. So we do that. Therefore, density of ideal gas is 2 atm times with 50 gram per mole, okay, over 0.0821 liter HCM per mole per Kelvin and 300.15 Kelvin. Okay, so we can cancel out atmospheric pressure. We can cancel out mole. We can cancel out Kelvin. You get gram per liter. So what you get is somewhere around 4.06 gram per liter. That is the density of your ideal gas. So it's very simple. It's very easy. You just need to remember the equation, the formula for density of ideal gas, which is density equals PM over RT. And also you need to know how to derive that formula from PV equals to nRT, because it's quite important, because they might gonna ask you in exams. All right.